This podcast is sponsored by GoCD, an on-premise, open-source, continuous delivery server by ThoughtWorks. GoCD gives you complete control of and visibility into your deployments across multiple teams. To learn more about GoCD, visit go.cd/InfoQ for a free download.
Hello and welcome to the next edition of the InfoQ podcast. I'm Thomas Betts, a senior software engineer at Nordstrom and InfoQ's architecture and design Q lead. At the recent QCon conference in San Francisco, I spoke to Haley Tucker, who is a senior software engineer working on the Playback Features team at Netflix.
Hi, thanks for having me today.
So take a minute to introduce yourself.
My name is Haley Tucker. I'm on the Playback Services team at Netflix. I own and operate several services that enable the play button for Netflix customers and determine the optimal playback experience.
I'm sure a lot of our listeners are big fans of the play button.
At least when it works.
Yeah. So you had a talk yesterday, Stranger Things, and one of the first things you talked about was, I thought of it as fun with distributed systems and the things you run into, but it was weird data in the catalog. And I think without any details, people will probably assume, well, Netflix has to be a distributed system because they're huge and they're distributed, and then they read the internet and it says, you guys are spread around the globe. But you had a great quote from Leslie Lamport: "A distributed system is one in which the failure of a computer you didn't know exists can render your own computer unusable." And that sounds like something that happens a lot at Netflix. Is that correct?
Yeah, I mean, I wouldn't necessarily say a lot, but there's definitely, like, every outage, I would say, is a different example of that. Like, we're usually pretty good at, once an outage happens, we prevent that from happening again in the future, and then, like, the next little thing comes along, like, how in the world did that happen? So yeah, absolutely, that quote rings true.
Yeah, you try to never fail the same way twice.
Right.
But always plan for the failure. So what was the example you were talking yesterday, the video metadata service?
Yeah, so the way Netflix data architecture works is we have a bunch of feeds from different source systems, so our content providers or our studios that publish feeds, and the video metadata service takes those feeds, does some validation on them, produces one large image with a consistent API that the rest of the Netflix services consume. And so that image is uploaded to S3, Amazon S3, and then all of the services can download it so that the lookups to that data are very fast and local.
So since you guys try to never fail in the same way twice, what were the protections that were already in place, and why weren't they sufficient from causing that to cause issues spilled over?
Sure. So as I mentioned, when that video metadata service is processing those feeds, it's doing a lot of validation on the raw data already. So it's making sure that, types are valid, that it's able to merge the data in an expected way, and that we're not missing data, and that the title is actually ready to go live. There's like a bunch of checks that it was doing. But if you think about the way it's used, it's not using every single access pattern that the actual services are using. And so no matter how many checks it puts in place, it can't predict the way everybody else is using the data. And so what happened is when the data flowed out, we were using a slightly different access pattern than they were using in their checks, and we just hit another problem.
So bad data came in and it just caused unforeseen problems down the line.
Yep.
So how did you manage to protect that from happening again?
So we went through a few iterations of this, and there's still a couple of them running in production today. But in both flavors of that, we went through a method of testing. So the services that are using the data and consuming the data are actually the ones testing and verifying it before it rolls out to production. So the video metadata service is able to coordinate testing, and the consumers of the data are the ones actually writing the tests. So we can define what it means for that data to be valid and consistent.
Okay, and so that led to data canaries, or is that what you define as data canaries?
Yeah, that's what we defined as a data canary. So we take a small set of servers that participate in this canary stack, and we have a test infrastructure that can run tests against those servers using the new image.
So it isolated that, and you're now no more problems with the...
Not since the...
Not that problem again, I guess.
Not that exact problem. I think there's like a couple of use cases where we're trying to push data out quickly, like we have this fast lane. And in those cases, I think we've seen problems sneak through, but those are really small, isolated use cases, and so it's not huge customer impacts when that happens.
Right. And then your second chapter was on a vanishing critical service. What vanished? How did it go away?
So we have a really lightweight service that collects all of the logs from customers around the world. And what I mean by logs is while you're watching your movie, we want to get information on, was it successful? Did you see an error? What quality are you getting? Are you getting the resolution or the bit rate that we expect? And so we collect all of this logging data so we can analyze it and know how we're doing. And so the service that takes those logs is really thin and lightweight. It doesn't do a whole lot. It just funnels the logs through to store them in Cassandra. Well, that particular service crashed. It ran out of memory and crashed due to the video metadata blob being loaded into memory accidentally. And so because we weren't expecting that much memory to be used, it pushed us over our limit and we crashed.
And so once you identified there was a video metadata service, again, what did you do to prevent that memory getting so high again?
So you mean what did we do on that particular logging service to prevent that?
Right.
From
How
happening
did
in the
you
future?
isolate what the problem was, and then how did you?
So yeah, isolating the problem was actually kind of tricky because, as it turned out, the mechanism that loaded data into memory was turned off in the test environment and it was turned on in the production environment. So it took us a while to actually reproduce the problem in test because of that configuration difference. And then once we did that, it was clear, like, oh, it's this dependency way down in our transitive dependency graph that is loading this data. And in fact, it's not even needed. This jar isn't even needed on the box. And so that gave us several different ways to attack the problem. One of those, which we still haven't been able to do, is to actually prune that dependency graph and get the jar completely off the box. That's still a work in progress. But we have been able to work with the video metadata team to implement a kill switch. Like, since they're the ones, like, ultimately that load the data, no matter which jar in our class path actually touches it, since the video metadata team owns the loading of it, we had them implement a kill switch. So, like, the team that's closest to that data can actually turn it off now. So we're able to configure that app to never load metadata. The nice part about that is if we ever needed to in the future, we can turn it on, we can move to a different instance type in AWS. Like, any test that needed that data would fail. And so we would block it before actually getting out into production.
You said that you're trying to prune the dependency tree. Have you worked on that? You said it was large.
Yeah, so we had 14 pages of jars in that application.
It's a lot of jars.
Yeah, it's a lot of jars, and it's really a remnant of the fact that this service was just built in an existing monolith. So, and we kind of sharded it off into its own app, and so it pulls in all the same dependencies as that other application does. So pruning that dependency tree really is a matter of actually cloning the pieces of the code that we need into a separate app and just loading the dependencies that app needs, and so that part hasn't been done yet.
And so the kill switch, is that similar to a circuit breaker, or is it more specific to that?
It's more specific. So I'm talking about like having a config value, whether you set that in a config file or whether you do an environmental override to say, do not load this data. Okay. Yeah, that's what I mean by kill switch.
Okay. And then how are you testing that in the future? Is this where fit comes into place? You guys are doing manual testing?
So as far as testing whether or not the data loads, we have some other mechanisms in place that should catch this in the future if it were to start loading again. Like, we added memory usage to the canaries. So when that rolls out, we should catch problems with memory loading. The other problem that we ran into during this particular outage is that when the logging service went down, we had a cascading failure to our proxy tier. And that's kind of where fit comes into play, because the proxy tier had circuit breakers implemented on them. And so what should have happened is that circuit breaker would have realized that the requests to the logging service were failing at over 50%. It should have opened, it should have stopped sending traffic, and it should have stayed up and healthy. But that didn't happen because we had a config value set on that tier that forced the circuit breaker to stay closed, and so those protective measures broke. So fit testing is what we use in order to verify that those circuit breaker mechanisms and the protective features that we have in place are actually functioning. So you can go and say, okay, fail all requests to this logging service and make sure that the proxy service stays up.
And FIT, just to define the acronym, is failure injection testing?
Failure injection testing.
And that's manually done? So you say we're going to run a FIT test and then you execute it?
Yeah, so you can go out and, so right now it's all manually done. You go out and you say, I want to run a FIT test, and you define your scenario. And your scenario can be, I want to fail all of these dependencies. I want to fail just one dependency. I can add latency. I can fail a cache, various mechanisms. So you can define the scenario and then run that either on a small scale, meaning like I just want to do testing for one customer and make sure things are working, or you can do large scale where we actually say, okay, none of these services should be critical. We should be able to fail them all and make sure that customers are not impacted.
Okay, and what do you define as critical and non-critical? Is it customer facing as critical? And
for playback, we define critical as anything impacting the play button. Like the customer is pressing the play button, they're ready to watch their show, and we want that to go ahead and start for them. So yeah, anything in that realm would be critical. Anything non-critical would be kind of more enhancements or customer experience. So things like if you want to prefetch a bunch of playback related data as an optimization so you can start really fast, that would be more of a performance improvement, or an experience improvement, such as when we're learning your audio and subtitle preferences so that we can make better recommendations for the next time. Like those are nice to have conveniences for the customer, but we don't want to cause playback to fail because of them.
I'm trying to remember all the details in your talk. It was really good. People can watch the video online soon. I think the third chapter you went into was throttling. So you had calls, you guys were watching the data and you saw calls slowed down, and then before you could figure out what the problem was, they sped back up.
Right, yeah, so we were just seeing these very regularly spaced spikes in latency from our service to one of the downstream services. And basically every 40 minutes we would see the spike in latency, and at the same time when those requests would fail, the retries were also failing. So we had like a period of 2 to 5 minutes where those requests were just failing and they were backing up on our service. And then as a result of that, we were noticing that we were throttling a small amount of requests upstream from us as well. Because as you're processing requests, you know what your application can handle. So you know I can handle X number of concurrent requests. Mm-hmm. And so that's how many you can accept. And if your latency starts to back up, then you're not processing those off as quickly, so you start rejecting requests in order to shed load.
Giving like a 503 response.
Correct, yeah.
And so how did you manage to keep the critical stuff up and running? Was everything getting rejected at that point? The critical and non-critical requests were both failing?
Yeah, so the problem with throttling is it's indiscriminate. So once you reach that number of concurrent requests, any number over that is just rejected. It doesn't matter if it's that important traffic or not. And so what we did is we sharded our application into 2 stacks. So we actually had 2 sets of clusters, one critical and one non-critical. And what that allowed us to do was to run them with different kind of SLAs and different definitions of best effort. So on the critical cluster, we way over provisioned, so we had plenty of headroom to handle any scenarios that happened. We did retries, we did fallbacks. We basically did everything we could to ensure that traffic would succeed. The non-critical cluster, we allow that to run a lot hotter. We don't bother with retries. And yeah, we haven't quite turned off the fallbacks yet, but that's coming up in the next month or so. We're waiting on one more fix to the client there.
You sharded your application into 2 stacks. Would you ever divide it more? Like, is there a lot of code? It sounds like this is now 2 smaller monoliths.
It is.
Would you go full microservices and start chopping more if you could?
Yeah, we would. And actually, like, even more so than that, we looked at a few of the use cases and I would move them probably to a different model entirely. There's a couple of them that are sort of fire and forget, so we could do something like publish the message to Kafka and then have a batch processor just listening for messages on Kafka and processing those independently. So I think when we did this was an effort to buy us some time and buy us some runway. We wanted to make sure that we could stay up and resilient without having to make a lot of architectural decisions right at that point in time. And it also wasn't hugely expensive operationally to stand up the two sets of clusters. And so what we're looking at doing going forward is reevaluating some of these calls and saying, like, can we do something better? Can we split it out more? And so like any of the new applications we're building are exactly that. We're building new little mini microservices instead of building them into the same stack. Okay. And then we're planning to move some of the other calls off into other patterns looking forward.
Switching gears a little bit, with the idea of planning for failure is something that you hear about in Netflix all the time. How does the culture embrace that? Does every employee and every engineer recognize that failure is going to happen and embrace it and be like, yay, we failed, let's not do that again? Or is there blame going around when something goes wrong?
I would say, like, definitely within edge engineering, I've seen that it's fully embraced. There's actually sort of a joke where once somebody breaks something in production, then you're like, welcome to the company, because it's just bound to happen. Like, and so like that's an example of where, like, instead of making somebody feel bad that they broke something, they're like, hey, yeah, now you're an employee. You know, you've been here long enough that you've actually managed to do it. So I think people have a pretty good outlook on it, as long as you're going the next step and learning from that and trying not to fail the same way twice. And so everything I've seen since I've been there, people do a really good job of rallying around a problem when we actually do have a big outage, and you'll see resources get reallocated to make sure that there's enough attention put on resolving that underlying problem. And you'll see other teams engage where they need to. And so it's pretty supportive.
When you see some little bug happen in the code and it causes a problem in production, is it a tendency to, well, we'll just fix that right here? Or does it lead to, how do we put that problem into our failure testing plan, whether it's a manual test we can run or an automated system?
Yeah, so I would say it's probably both. Usually we go ahead and fix that underlying bug, and then you'll see a variety of things. If we have existing tooling where we can go and add a new scenario, I've generally seen teams be proactive in adding those scenarios there. Just like if you have a regression failure, you go and add a regression test. For new things like the way Fit, came about, or the way different frameworks come about, a lot of times you'll see that show up in like a hack day. So engineers have this idea and it's kind of, burning in the back of their mind, and every 6 months or so we have a hack day and they'll go and implement it. And then, so the data canary architecture was actually part of a hack day project. Oh. So it was something that we had a hack day not long after that outage, and we were saying, I think we can do this better. And so we went and actually built an example of a data canary.
You also mentioned yesterday that the next generation after Fit is more automated. What was
ChAP.
that? ChAP.
Yeah, it stands for Chaos Automation Platform. And basically it's the idea of, now you've gone and you've defined all of these different scenarios for running your tests, and you run them manually, but now let's do this on a regular ongoing basis. So like with every server push, let's go ahead and run these failure scenarios so that we're proactively checking for these things with every push and making sure we don't have regressions.
And since your talk was kind of focused on, and it's not the first Netflix talk I've watched where it's, here's all the failures we have, and here's how we embrace them, and here's how we change. We have Chaos Monkey and all these stuff. How much of your time do you get to spend writing new features, or is it really a lot of responding to these problems?
Yeah, so especially over the last several months, I've spent almost all of my time working on new features. So I think it varies depending on the time of year and what all is going on, but a lot of that is about staffing. And so we've been slowly staffing up over the last couple of years, and so now we're at a point where we have more headroom where we can invest in absolutely new capabilities. Like week-to-week operations, we try to have just our on-call person focus on all of the crazy going on in production, and they're basically fighting fires, and then that way the rest of the team doesn't have to get pulled into it so far. And I think it depends too. Like when I said I'm working on new features, I would say we're working on some new tech stack. New product features are there all the time. So there's probably 20% of our work is constantly supporting new product features.
So the playback services, this is more from my curiosity, I guess. Where does it fit in the stack? I've seen the slide of here's our edge, and then here's the API, and then there's this soup of microservices behind it. Where do you guys fit in that?
We're a little bit of both. So my team owns 2 of the microservices that are in that big, microservice soup. But then we also contribute code to 3 different edge tiers.
Okay.
So depending on what snapshot in history your device is from, you may hit one of 3 different edges for all of the playback data. And so we basically have our client that remotes to the mid-tier running on each of those edges, along with like some translation code and a few business rules that go with it.
So if I have a Roku 2 versus a Roku 4 versus an Apple TV or an iPhone, those all might go different paths.
They all may go very different paths. Wow. Yep.
And how do you keep track of all that?
We pretty heavily leverage Elasticsearch. We log just about all of our requests and responses for the critical playback data into Elasticsearch, which has been amazingly valuable because we used to have most of our stuff going to Atlas, which is our kind of alerting and insights tool, but that's pretty coarse-grained. So you would know like this particular error is happening. You might know the country or the device, but like that's it. So with Elasticsearch, we've actually been able to see, this error is happening, but it's across these 3 titles, or these 2 device types, or there's this one flag being set on the request, or it's a particular A/B test. And so it's like made it much easier to kind of drill down quickly and find the common ground between failures.
Yeah, I know that's one of the challenges with most microservice architectures. We have this one service that just does this one thing, but it's part of this big, massive network. And when anything goes wrong, being able to trace through that and find, what was the path that went down, and what's the commonality?
Right.
So find out you guys have that's built up. I'm assuming there's teams that work on adding that capability for the engineering teams to do that better.
Yeah, so there's a couple of areas. Like the Elasticsearch stuff is just something that we've built on our mid-tier. We don't own the Elasticsearch clusters, but we're publishing data to them. And so that's more just focused on the requests that we get. There are teams within Netflix that are looking at the more traceability aspect of it. So tracing a request from the time that it hits the proxy tier all the way through to every mid-tier, so you can have that graph of every service that it hit and how long each service took to operate and like where your bottlenecks are. So yeah, that's a slightly different thing, but there's definitely teams working on that as well.
And then what's the most exciting and fun thing you've worked on in the last 6 months?
I think the most fun thing we've been working on my team is we're actually looking at taking the data that's in that video metadata blob and processing the changes to that, and then storing like pre-computed views of it into Cassandra. And so like when we were running some load tests, we found that one of the most expensive parts of our request processing was actually taking the data from the video metadata client, converting it into the objects that we wanted to deal with, and then pass it. So it's just like this translation layer. And for the most part, those objects aren't changing from like, if I get House of Cards Season 1 once, that object isn't really going to change if I call it 50 more times in the next few seconds. And so being able to compute that once and store it in the form that we want to store it in would be hugely valuable, and it would cut down a lot on our CPU utilization. And so what we've been working on is these little batch loader pipelines that can listen for changes to data, store the objects in the format that we want them, and then we have a really high throughput service that's serving that data. So
very cool.
It's pretty fun.
Yeah, it's pretty geeky stuff.
Yeah.
But yeah, it sounds like a lot of fun to work on. Any last things? Are you going to be speaking anywhere else that people might see you? Or?
No plans to speak as of now.
All right. Well, thank you very much for your time.
Thanks for having me.